From Corporate Connection. For your information, hello viewers and subscribers, please contact us on contentcorporateconnection@gmail.com for artificial intelligence projects, machine learning projects, deep learning projects, Python projects, and Java projects for all degree students and polytechnic students. Imagine you receive an email. Within seconds, your email system decides whether the message is spam or not spam. Have you ever wondered how a computer can make that decision so quickly? Or imagine a hospital system that predicts whether a patient might have a disease based on symptoms, or a movie recommendation system predicting what you might enjoy watching next. Behind many of these intelligent predictions is a powerful yet surprisingly simple machine learning algorithm called naive Bayes. Hello everyone and welcome back to the channel. In today's video, we are going to understand naive Bayes algorithm explained simply, step by step, in a way that even complete beginners can understand. We will explore what naive Bayes is, how Bayes theorem works, why the algorithm is called naive, real world applications, advantages and limitations. By the end of this video, you will clearly understand how naive Bayes works and why it is one of the most widely used algorithms in machine learning. So let's begin our journey. Naive Bayes is a supervised machine learning algorithm used mainly for classification problems. Classification simply means placing data into categories. For example, an email can be classified as spam or not spam. A news article can be classified as sports, politics, or technology. A medical diagnosis system can classify a patient as healthy or deceased. Naive Bayes works based on probability. Instead of making guesses randomly, the algorithm calculates the probability that something belongs to a particular class. Then it chooses the class with the highest probability. The algorithm is called naive Bayes because it applies a famous mathematical rule called Bayes Theorem while making a very simple assumption about the data. This simple assumption is what makes the algorithm fast, efficient, and surprisingly powerful. Now let's understand the mathematical idea behind the algorithm. Naive Bayes is based on Bayes theorem, a fundamental rule in probability. Bayes theorem helps us calculate the probability of an event based on prior knowledge. The formula is probability of A given B equals probability of B given A multiplied by probability of A divided by probability of B. Although the formula might look complicated at first, the idea is actually very simple. Let's consider a medical example. Suppose a disease is rare, but a medical test comes back as positive. Bayes theorem helps calculate the probability that the patient actually has the disease, considering both the test result and the existing probability of the disease. In machine learning, naive Bayes uses this principle to calculate the probabilities for different classes and choose the most likely one. Now let's understand how naive Bayes actually makes predictions. The algorithm follows three main steps. First, it calculates the prior probability of each class. For example, what percentage of emails in the dataset are spam. Second, it calculates the likelihood, which means how likely certain features appear in each class. For example, the word free may appear frequently in spam emails. Third, it combines these probabilities using Bayes theorem to calculate the posterior probability. Finally, the algorithm selects the class with the highest probability. In many diagrams of naive Bayes, you will see arrows connecting features to the final prediction. Each feature contributes independently to the final decision, and all probabilities are multiplied together to determine the final result. Let's look at a simple real world example. Imagine a dataset containing medical records of patients. Each patient may have symptoms like fever, cough, fatigue, and each patient is labeled with whether they have a disease or not. When a new patient arrives with symptoms such as fever and cough, the naive Bayes algorithm calculates the probability of disease based on past data. If most patients with those symptoms had the disease, the probability will be high. If those symptoms rarely correspond to the disease, the probability will be low. Based on these probability calculations, the algorithm predicts whether the patient is likely to have the disease. This approach is widely used in medical diagnosis systems. So, why is the algorithm called naive Bayes? The word naive refers to a simplifying assumption rule by the algorithm. Naive Bayes assumes that all features are independent of each other. In other words, it assumes that one feature does not affect another. For example, in email classification, the presence of the word discount might influence the presence of the word sale. But naive Bayes assumes they are independent. Although this assumption is often unrealistic, surprisingly, the algorithm still performs very well in many real world applications. This simple assumption makes naive Bayes extremely fast and efficient, especially when dealing with large data sets. Naive Bayes is widely used in many real world applications. One of the most famous applications is spam email detection. Email systems analyze words in the message and calculate the probability that the email is spam. Another major application is sentiment analysis, where companies analyze whether customer reviews are positive or negative. Knife Bayes is also used in document classification, news categorization, medical diagnosis, recommendation systems. Because the algorithm works well with text data and large data sets, it remains a popular choice in many AI systems. Naive Bayes has several advantages that make it very attractive. First, it is very fast to train. Unlike complex algorithms that require heavy computation, naive Bayes can learn quickly. Second, it works well even with small training data sets. Third, it handles high dimensional data very efficiently, which means it can work with datasets that have many features. Fourth, it performs surprisingly well in many real world problems, even though it makes the naive independence assumption. These advantages make naive Bayes a strong baseline model for many machine learning tasks. Despite its strengths, naive Bayes also has some limitations. The biggest limitation is the independence assumption. In real life, features are often related to each other. Another limitation is that the algorithm may struggle when certain feature combinations never appear in the training data. This is known as the zero probability problem. To solve this issue, techniques like Laplace smoothing are often used. Understanding these limitations helps us choose the right algorithm for the right problem. Let's quickly summarize what we learned today. Naive Bayes is a probability based classification algorithm. It uses Bayes theorem to calculate probabilities and make predictions. The algorithm assumes that all features are independent, which is why it is called naive. Despite this simple assumption, naive Bayes performs extremely well in many tasks, especially test classification. It is fast, efficient, and easy to implement, making it one of the best algorithms for beginners to learn. Now it's quiz time. Try answering these questions and send your answers to contentcorporateconnection@gmail.com. Here are today's 5 quiz questions. What type of machine learning algorithm is naive Bayes? Options. Choose one option and send in the mail. 2. Why is the algorithm called naive? Pick an option of your choice. Third, what mathematical concept is naive Bayes based on? Choose the right answer. Fourth, which of the following is a real world application of naive Bayes? Pick an option of your choice. Last one, why is naive Bayes particularly useful for text classification? So these were today's 5 questions. Send your answers to the email address mentioned and let's see who gets them correct. If you found this explanation helpful, make sure to like this video, comment your thoughts, subscribe to the channel for more machine learning tutorials. Thank you for watching and I'll see you in the next video, and do not forget to drop all your answers to contentcorporateconnection@gmail.com. I'll personally review your responses and feature the best answers in our upcoming sessions, and also be the one to get all the goodies and toolkits and free AI training course absolutely sponsored from Corporate Connection. So thank you for watching and do not forget to subscribe to the channel for more machine learning tutorials. Thank you.